Alright, welcome back to Meteorology 101. This video I'm going to just go through the weather charts, look at the SPC, some enhanced warnings for severe weather to the north, and we're going to go pull whatever charts we get into. I'm going to start with the surface, and then go to the upper air, even though you get a lot of your data right around 500 millibars. That's 18,000 feet. Pretty much want to start there, and then you can work your way down, because the mid levels and upper levels is what's really going to tell you how significant a system is. But I always start with the surface chart just to see what systems are on the surface, and then we go to the upper level to see which systems have support, and then look for any upper level systems. So right now we're going to do sea level pressure since we're on the surface. Alright, so we do have that lee side low right there in eastern Colorado. So this is a pretty huge system, pretty much covering the whole United States. The high pressure systems, that high was absorbed into the subtropical high, and that's pushing off the east coast. So we do have the southerly flow, so this could bring a lot of moisture from the Gulf, pushing up into the Gulf states. And then depending on the intensity of this low, which is 994 millibar low, it's pretty intense, dragging that moisture. We'll see how far that goes. We'll pull some dew point data and see where our dew points are in this area, so we can determine where the major threat is for severe weather. Right now we're going to do the isotherms on the surface. I use Celsius just so I can see the thermal advection. Like I said, there's a warm core system. If you watched my last video, we talked about that. It's a warm core system in the south, and then really not a lot of thermal advection in the Gulf states. But all of our thermal advections further north up through Missouri and pushing up into the Great Lakes region. So, and then you can see how the thickness, the temperature packing gets tighter over Minnesota, over the Dakotas, down in Nebraska. Right there is our thermal ridge. So right in this area would be the enhanced area for severe weather. So let's pull our surface data, see what the dew points are. So temperatures 65, dew points 59. There's a 64, 61, 65. So pretty much right through that area. Anything 60 or higher on that dew point, you're looking at an increased possibility of severe weather. So let's put the fronts on here. Like I've said before, these things get a little cluttered, but we'll get the fronts on here, and then I'm looking for maybe a warm front dropping down right through this area, right through Kansas, Arkansas, down into Tennessee. That's where I see the leading edge of that warm air advection. Cold air advection, I would have to go back to the west, maybe into Southern California for the cold air. That's the leading edge of that cold air advection. So let's put the fronts on, see what the computer does. So NCEP pretty much messes this up quite a bit. So they're just going stationary up to the north, stationary coming out of another low, stationary dropping down back into the main low, and then stationary coming out of that. So they're stationary everywhere. They get a little bit of warm air advection in the Gulf states. I don't see the advection there to back that up. We'd have to pull a thickness chart to verify that, but I'm not seeing it. So these fronts are pretty much useless. So get rid of those. I can draw on the screen myself. So let's go see what I got for let me get my draw tool up here. so I'm going cold front out of this low. I would have to drop that back, like I said, into Southern California. Warm front. There is a little bit of thermal advection right here, but it's pretty weak. So maybe drop that down a little bit and do a warm front right there. So with that warm front, as this low pressure system pushes to the northeast, we'll have to see the direction of this low. Could be going that way, could be going that way, could be just sitting around here moving around just directly to the east a little bit or something. So we'll pull up some models, see where that's going to go. But let's look at the mid levels too. That's your steering flow, is the mid levels, to see which way this thing goes. So what you would initially look for is a jet stream come up across this, maybe a subtropical jet to the south. But this polar front jet, if it's dropping to that far to the south, looking for some snow in that area. And then this thing either going to be crossing this low, becoming a little more zonal right through here. Get a little messy here. So we go our fronts, jet stream, look for something like that. Or we could go like this and then back up around that system. Sometimes you get them cut through the low, sometimes you get them going around the low. We do have a pretty strong thermal ridge, so this thermal packing right there, so it almost looks like it goes like that. So we'll pull up the 300 millibar jet stream, see where that actually is too, and what support we have for this low. Alright, so pretty much that's the surface. We're looking at this area up here around that thermal ridge. Let's go pull the SPC. Let's see what they got real quick, and then we can look at their data, verify our data against theirs. There's the models. Here's the SPC, Storm Prediction Center. So they got it through from Nebraska all the way up to Minnesota for that enhanced area. They have a slight chance in Florida, and then a whole slight chance pretty much throughout the whole upper Midwest. So we're looking at that enhanced area. Like we said, our area was right through here where the highest dew points were. So we'll have to see where that low pushes off to and then go from there. So let's get back to our weather chart. Alright, let's go to the 850, see what we got there. We're keeping an eye on this low. Now we want to see where that center is right there. So we're over western Kansas, southwest Kansas. Let's see where this low ends up on the 850. Let's get rid of this. Pull up the heights, the lines of equal height. Alright, so we shot pretty much straight to the north from southwest Kansas over Nebraska. That stacks that to the colder air like it should. Look for some thermal advection. Still got a warm core system to the south. And then we can bump up our station plots on the upper levels so we get all the data we can get. Now one thing we didn't put was the moisture. If you look at all the black stations, that's where all your moisture is located, right there, pretty much in that enhanced area. So at 5,000 feet we are saturated through down to Texas and Kansas, Mississippi. and then Ohio over to the East Coast. All right, so there's the 850. We stack straight to the north, straight to the cold air. Pretty much still have that same sort of system, a pretty strong thermal packing here. So we do have an upper front. We could pull that out to out of this thermal ridge right around where a thermal advection might be. Pretty much do another almost vertically stacked. Maybe jump back a little bit. Be a pretty steep slope on that. So we're going to have to keep an eye on that as this thing pushes north. See what that frontal system does, how steep that slope is going to be, and how much of that more moist air is going to start plowing through to create that severe weather. Now our severe weather is going to be to the north of this low, so we got the warm air advection. So as that warm air pushes up, then that's where our area of severe weather is going to be with the wraparound right around that low pressure system. Alright, so there's the 850. Let's go to the 700. Turn this off. Okay, so we were over Nebraska for our low center. Let's look at the 700. Alright, so now we're stacking a little bit more to the west from Nebraska. Pretty good jump there, and then our low pressure system is still pretty significant. Still baroclinic on the cold air side. Pretty much some warmer advection right over Minnesota. Pretty weak, but it's there. We're becoming barotropic as we get up into these upper levels. So we don't have a lot of thermal advection associated with this, at least on the east side of that low. We're baroclinic on the backside, so we do have that cold air advection back there still. So like I said, as this thing pushes to the northeast, it looks like our flow is pretty steep there. So the 700 millibar, let's go pull our station plots real quick. Alright, do we get it? Alright, so we need to look at the moisture also, but right now still have thermal advection all the way through here, pretty much all the way back to Southern California also. Really not a lot of thermal advection to the north, so but we're looking for this low that started down here, stacked here, stacked back to there, pushing. This is our flow, so we're looking at about 20, actually probably about 30 knots or so, just under 30 knots movement to the northeast. I'm going 70% of the 700 millibar winds. That's going to be our approximate speed of this low pressure system. The steering is pretty sharp straight to the north, so northeast. That is going to be the flow of that low pressure system. So that's how we're getting that wraparound moisture over the Dakotas, Minnesota, and giving us our enhanced area for severe weather. Alright, so let's go up to the 500. Typically I put moisture on here. I let the computer analyze the moisture so we can see where, if we're still saturated, but we can see that just from the station plots too. We don't have to have the green on the screen to see that. So if we look at this one, now our low pressure system went away. We are still we got some thermal advection here. So our low would be up here. Weak thermal advection right through this area. So we do have that upper level trough with that thermal advection. So we're pretty significant there. And our flow right there is going to be 50 knots. That's 25. There's a 65. So 3750. 37 knots to the north-northeast. As that system catches up with the surface system and then becomes vertically stacked. But that's going to happen. That'll be over the next couple of days possibly, but we're going to watch this low pressure system push to the north, cause our enhanced area right around where the low is going to be, and then watch for severe weather pretty much anywhere there's saturation. Right here is at 500, so we're saturated in that area. So we're still there. We got the saturation, we got the moisture. We need moisture, instability, and lift to cause our thunderstorms. Now let me get my draw tool on here so you can see it. I got, like I said, the low right around this area. A little bit of thermal advection right here. Gets weak right there. Weak right there. So we have thermal advection in this area. And like I said, there's the 50, 65 knots. There's a 30. There's a 50. So our movement to the north-northeast. And then we are saturated here. Saturated there. Saturated there. So let me clear that off real quick. And then we're going to go saturated there and there. And then all of this. So like I said, anything up here, we're looking at the 540 line. That looks like that's well to the north. So, but possible some snowfall in the northern Rockies. Keep an eye on that too. We'll go to the models and look at that. Let's pull the jet stream. Let's verify where the our surface low was in southwest Kansas. We want to see where the jet stream is associated with that low also. Let's go 300. Pull the jet stream. Pull the contours. Isotherms, and then station plots on there. So now we're barotropic. We are saturated in this area though. Saturated on eastern Nebraska. Here's our flow, the jet stream. So here's our low. So like I said, that's going to shoot up around pretty much right, more or less right through here. Kind of right through that low. Because of the wind speeds I'm looking at. We're looking at 65, there's a 60. There's 85, there's 100. So let's go back right through this area. We'll have to pull a thickness chart too. That'll give us an idea where our jet stream is, but this is pretty much it right here. Going through that jet max. Drop that down south a little bit. Support that low pressure system. Pretty much cutting through the low on this one. So we do have the exhaust right there with the jet going over that low, sucking the mass out. Going to deepen that low and then steer that to the north-northeast, and then keep that intensifying as it moves. So we're looking at a pretty significant system pushing through there. So I'm agreeing with the SPC, that severe weather to the north. They had a little bit of chance in Florida. That's we're still saturated down there. No thermal advection, but we have to go back to the surface, see what our dew points are. Actually, let's go back and do that because I want to see. Let's go run some upper air charts. Alright, I want to run a dew point. Let me go back to moisture. Dew point shaded. This is going to be in Fahrenheit. So we can see our dew point shooting all the way to the north. Alright, let's go get that outlined with the actual dew point temperature, the isotherms. So here's 60. Go back on the draw. Alright, so right there. Let me turn that on. I didn't exactly get that turned on yet. Alright. So there's the area of 60 or greater. Pretty much anything through this area. Which you're always going to have 60 or greater down here. That's pretty much a given. Sometimes it dries out along the Gulf states, but Florida pretty much, anytime you got moisture over Florida, you're pretty much 60 or higher on that dew point. So look, here's the 60, 55. So you still got that slight chance there. They're going enhanced right in this area. So as this pushes through, that low pressure system pushes to the north and interacts with this moisture, you're definitely going to have that area of severe weather. So let's go look at some stability indexes. Let me run the total index. Stability index from the Scooties. We're looking for anything 50 or greater. Value of 50 or greater is for thunderstorms. Alright, so we're hitting a 52 there. That's pretty much general thunderstorms all through this area. Now, as that system pushes to the northeast, interacts with that moisture, that 60-degree dew point, then you are definitely going to go enhanced. These numbers are going to go up. This is current data. This isn't forecast. This is nowcast data. So that's where we're getting the 50 to 52 already. We're already got an area of general thunderstorms. Not going to take much for those to become severe with those 60-degree dew points. Alright, let's see what else we got. Run a low-level shear. Let's go pull the low-level wind shear. See where the low-level jet is. Right there, pretty much where we need it. So we got the low-level jet. Pretty much right where that 60-degree dew point comes up. We're going to shade right over top of that. So right there is where the dew point is. We can overlay that. Now, so we got the low-level jet. That's another significant feature we're going to need for tornadoes. So we could have a possibility of a tornado outbreak in this area. Alright, let's go see what else we have. We could do lapse rates. Alright, see how much the temperature changes per 1,000 meters. We'll get a temperature drop of 8 degrees or higher is going to be the enhanced area for severe weather. So 7's pretty good. 6 is average. Like 6.7 degrees Celsius is average. There's a 7. And then 8 is when you're getting into a steeper lapse rate. So as the temperature cools at a higher rate going into the upper levels, that's where you get this enhanced area. Now, like I said, this is nowcast. Once that low pressure system shoots to the northeast, this is going to push to the north with it. And that's going to change. So definitely going to get, we got the instability we need right there. Alright, this lapse rates, let's go, so I got a potential precip. I don't use this one too much just because, let's see, let's go precipitable water. Let's look at how much precip is there's a potential if there's not going to be any flooding with this. This is sometimes not 100% accurate, but here's 1 inch right there. So we got the moisture, definitely got the moisture in the area too. So pretty much everything lines up right there for that area for severe weather, heavy rain, tornadoes, pretty much everything you need. All the ingredients are there. Let's see what else we have. We'll go to the models in just a second. And then run through those real quick and then call this thing. But right now we're at just under half an hour. So, alright, let's look at. Let's run that thickness chart real quick. Really ain't gonna tell us anything. We already know about what the jet stream was. So we're not going to really bother with that one. Let's go with another stability index here. Thermal advection Kelvin, the Kelvin scale. Alright, this is putting really enhanced down in the south. Right there where that warm core system is. Well, that's a little bit further to the south actually. But right there, Minnesota. We got a 0.1. That's where you're getting into the enhanced areas. Actually over Indiana and Ohio too. So maybe possibly look for some thunderstorms in those areas in the next couple of days. Then we got, and then over Florida. But I'm going to stick with this area up here where the SPC has the most potential. This chart is, it gets a little extreme sometimes. I got one that is a little bit weaker. Let me go find it. Sometimes it does a job, sometimes it doesn't either. So I'll take these with a grain of salt. Right there over Texas, that's because of that warm core down there. Little bit of area over Minnesota, and then we'll still have that area over Ohio, Indiana, Illinois. Alright, so this is nowcast stuff. It's not forecast. Always remember that. Any charts that I pull are all current data. It's based on current data, not forecast data. Alright, let's get to the models. Alright, we're going to pull the United States. Let's go down here to try to get as much room on the screen as I can to let you guys see the dates and times. Alright, so we're going to push through. This is currently 21Z. This is a few hours behind. So here's the low pressure system right there over southwest Kansas. So you watch that. Kind of sits there for a second and then pushes up almost straight north. It's northeast. Becomes pretty intense. And then pushes up north of the Great Lakes region up into Canada. Now, looks like high pressure starts to ridge in. So I'm going back and forth here. Bring that low back down. Push it back to the north. There's our snow we were looking for. Wyoming, Idaho, Montana, maybe some heavy snow in those areas. Okay, there's the low pushing to the north. High pressure ridging in. Looks like some precip associated with that high too. That low kind of circling back around. And then just wandering around right there in Canada. So and then looks like precip kind of hanging on. Looks like a low pressure system down here over the Gulf, pushing across Cuba, maybe into Florida. At least causes some precipitation down there in southern Florida. A lot of scattered stuff all the way through the southeast U.S. Alright, so this is Friday, June 3rd. And then just minor short waves just pretty much all around this high pressure system. And it looks like that system down there comes out of, go back, comes out of right around the Yucatan Peninsula, pushes up the east coast, pretty much out to sea. Another disturbance, maybe a clipper pushing across the northern U.S. That system gets pretty intense out there over the Atlantic, though. Starts pushing to the north. Have some major, a little bit of impact on Maine, possibly. And then let's go back. So high pressure, a lot of short waves around that high, creating instability for that precip. Look like another system coming out of the Yucatan. That looks like a pretty intense system right there. And then that ends. That's way out there. That's June 14th. 384 hours, pushing up into southeast Texas. So we'll have to keep an eye on that. Probably going to end up somewhere else or not at all. Looks like another system up to the north, kind of clipping through. 998 millibar. So we have to keep an eye on that one too. That could be enhanced area, but that's a while out. We're not going to really worry about that. Let's go back. Let's go over the next 24 hours or so. Here's a 6. So this isn't really showing like an intensity. Let's go to convective. Surface-based cape. There's some serious cape right there, 3,800. And then it kind of just falls apart. Now you got 21Z on Monday. That gets pretty intense. So that would actually be for tomorrow, May 30th. That would line pretty much right up with the SPC. So that's where they're getting at. That could be a pretty significant tornado outbreak up through there. Let's get back over there. I don't know why this resets, but okay. So 3,000, 3,300, 3,600. So I'm seeing 3,696 on the Cape. So let's look at our data here. On the Cape, we are looking at, let me find it on my chart. Pretty much strong, widespread, severe storms. And then greater than 4,000 value, greater than 4,000 extreme, large hail. So we were pushing 3,600. I mean, we're going to be looking at large hail, significant weather. That's going to be a heck of a storm up there. So if you're in the Dakotas, Minnesota, that'd be something to keep an eye on there. So that's through Monday. Then that kind of dies out, and then you get a little bit more Cape. At least you have the energy over Oklahoma up into Missouri, and that's out to Tuesday. So any precip for Tuesday, let's look at right there. So possible some thunderstorms right there, but we're looking at this one for tomorrow over the Dakotas, Minnesota. Keep an eye on that for severe weather. So that's pretty much it. We're just over half hour, so I'm going to call this. I want to say thanks for watching. Visit my website, meteorology101.com. And until next time, get your head in the clouds.